This video is about vectors, and this is part 1, and it's found in section 6.3 in the textbook. A vector is used to represent a quantity that has both size, magnitude, and direction. Examples would be velocity or force. An object has a certain velocity, meaning the magnitude would be the speed that it's going, and the object also has a direction that it's going in. Okay. A vector is represented geometrically by a directed line segment. So that means you have an initial point and you have a terminal point. Right? And then that would be the direction of it. If you know the names of the points, say this is point P and this is point Q, you can call this vector PQ. Write the initial point first, then the terminal, and then you need to write the vector symbol above it, which looks like an arrow with half of one of the little parts to it. Okay. Many times a vector will be named with a lowercase letter. U is a common letter, and again, you have to put the little half arrow thing above it. Right? In a textbook, many times a vector will be represented by putting something in bold print, right? But when you're writing it by hand, you have to put the little arrow on it to show you're talking about a vector. The magnitude of a vector is represented by the length of the directed line segment. Here are two different directed line segments. They both have the same direction, so perhaps these could be winds in a weather report. They're both going in a northeast direction. However, this directed line segment has a longer length, and that represents a larger magnitude, and that would represent a stronger wind than this one. The notation for magnitude is you write the name of the vector and then you surround it with double vertical lines. All right? So that's the magnitude of vector PQ, for example. If you want to find the magnitude of a vector, this is one where the initial point is 1, 3, and the terminal point is 4, 9. You can use the distance formula. And that will give you the magnitude. So it would be, the distance formula is the square root of the quantity x2 minus x1 squared plus the square of the quantity y2 minus y1. All right. So if we're doing the distance formula here between P and Q, it would be the square root of 4 minus 1, so it's the difference of the x coordinates, plus the square of 9 minus 3, the difference of the y coordinates. And so that would equal 3 squared plus 6 squared. That would be 9 plus 36. So that would be the square root of 45. If you simplify it, 3 times the square root of 5. So the magnitude of PQ is equal to 3 times the square root of 5. Two vectors are considered equivalent when they have the same magnitude and the same direction. Here's a question that is similar to some of the exercises in the textbook. Show why vector PQ is equivalent to vector RS. And I am assuming that vector PQ was the one in the last example. Here is the initial point and the terminal point of vector RS. So if I go ahead and graph point R, -6, -2, There's the initial point, and negative 3, 4. There's S, there's the terminal point. All right. Looking at the two vectors, they do look like they're the same length, same magnitude, and the same direction. Now, if they ask you to actually explain that, then you need to write out your work. So you would write out how you find the magnitude of PQ, which we have already done, and then we would find the magnitude of RS. So the magnitude of vector RS will be the square root of, subtracting the x-coordinates, negative 3 subtract negative 6 squared plus 4 minus negative 2 squared. So that will be 3 squared plus 6 squared. This is going to work out the way the other one did. The square root of 45, which is 3 times the square root of 5. Okay, so we can see that the magnitude of PQ is equal to the magnitude of RS. All right. How can you show that the two vectors have the same direction? All right. One way would be to look at their slopes. All right. If you find the slope of PQ, in general, the way you do slope, the formula M equals y2 minus y1 divided by x2 minus x1. So for P, it would be 9 minus 3 divided by 4 minus 1. So that would be 6 divided by 3. That would equal 2. And then if I do the slope of RS, the same idea, y2 minus y1, so that would be 4, subtract negative 2, and then x2 minus x1, negative 3, subtract negative 6, so that would be 6 divided by 3, and again, you wind up with 2.